So for today, I'm going to discuss Math Module Quarter 1, Week 6, Solving Quadratic Inequality. So let's go directly to Activity 1. Directions: find what is asked in each number given a mathematical sentence. So this is just a review in your lesson in grade 8. So in here, you're going to find the value of the variable. So for example here in number 1, n minus 3 equals 10, you're going to transpose negative 3 to the right side, so it will become positive 3. So you're going to have n equals 10 plus 3, so the value of n is equal to 13. Then what's new? So activity 2, directions: use the table below to identify whether the following equations are quadratic or not. Answer the questions that follow. So your questions will be your guide in answering this one. So you have there two columns, quadratic equation and not quadratic equation. So you will just put the given mathematical sentence or equations where they belong. What is it? So quadratic inequality is an equality that contains a polynomial of degree 2 and can be written with the symbols greater than, lesser than, greater than or equal to, or lesser than or equal to. So examples here: x squared plus x minus 12 is greater than 0. 7x squared minus 28 is lesser than 0. 5 is greater than or equal to x squared minus x. And 4, 2y squared plus 1, lesser than or equal to 7y. Then how to solve quadratic inequality. So quadratic inequalities can be solved using three methods here. So we have A, 3 test points, B, sign graph, and C, graphing. Then this is in two variables, x and y. So we have here example number 1. Find the solution set of x squared plus 3x greater than 10. So method A, 3 test points. So first step is you're going to write the quadratic inequality in standard form. So you're going to write this one into standard form. The right side should be 0. And in the left side, you're going to have the constant term and the variables. So x squared plus 3x greater than 10. So we're going to transpose 10 to the left side. So we're going to have x squared plus 3x minus 10 greater than 0. So next is you're going to make this one into an equation. So you're going to change the inequality sign to equal sign. So you're going to have x squared plus 3x minus 10 equals 0. Then using factoring, you're going to have the factors x plus 5 times the quantity of x minus 2 equals 0. Then using zero product property, you're going to have x equals negative 5 or x equals 2. Next step is you're going to find the three test points using negative 5 and 2. The points negative 5 and 2 can separate the real number line into three intervals. So x is lesser than negative 5, x is greater than negative 5 but lesser than 2, or x is greater than 2. So if we're going to draw a number line, so our three test points here are negative 5. Then let's have here 0. Then we can have here 2. Okay. So three test points, x is lesser than negative 5. So from this point, negative 5 up to negative infinity. Then x is greater than negative 5 but lesser than 2. So from 5 up to 2. Then the third interval is x is greater than 2. So x is greater than 2. So from 2 up to positive infinity. Okay, so that will be your intervals, the three intervals. Next is you're going to test a value from each interval in the inequality. So first interval is x is lesser than negative 5. So you can select any of the number that is lesser than negative 5. For example, you can have negative 6, negative 7, negative 8, or any number, as long as it belongs to this interval. So in this example, it used negative 6. So you're going to substitute negative 6 to the inequality. So you're going to have negative 6 squared plus 3 times negative 6. So substitute x with negative 6, then minus 10 is greater than 0. So negative 6 squared is 36, then 3 times negative 6 is negative 18, then minus 10 is greater than 0. If you're going to solve this one, 8 is greater than 0, and this is true. Now for x is greater than negative 5 but lesser than 2. So greater than negative 5 but lesser than 2, we can have 0, 1, we can have negative 4, negative 3. So these numbers are greater than negative 5 but lesser than 2. So in this example, you have there 1. So you're going to substitute the inequality with 1. So 1 squared plus 3 times 1 minus 10 greater than 0. 1 squared is 1, 3 times 1 is 3, so 1 plus 3, then minus 10. So 4 minus 10 is negative 6 greater than 0. This is false, not true. Then for the third interval, x is greater than 2. So you have there 4. Again, you can use any number as long as it is greater than 2. So you can use 3 and so on. So in this example, this is 4. So 4 squared, 16. 3 times 4 is 12. So 16 plus 12, then minus 10. So the answer here is 18 greater than 0, which is true. Okay. Now, since the given values of x to the given interval makes the equation true, this means that they are part of the solutions. Okay. Now, let's test the roots x equals negative 5 and x equals 2. Let's test this one if this one satisfies the inequality. So, if x is equal to negative 5, you have there 0 greater than 0, which is false. And if x is equal to 2, you have there also 0 greater than 0, also false, not true. So therefore, the inequality is true for any value of x in the interval. X is greater than negative infinity but lesser than negative 5, or x is greater than 2 but lesser than positive infinity. But points negative 5 and 2 does not satisfy the inequality x squared plus 3x minus 10 greater than 0. So the solution set of the inequality x squared plus 3x greater than 10 is x, such that x is lesser than negative 5 or x is greater than 2. So this will be your answer. Then second method, the sign graph. So first, you're going to write the quadratic inequality in standard form, just like the first method. So x squared plus 3x minus 10 is greater than 0. Then the same factor, the quadratic inequality. So you're going to have x plus 5, or quantity of x plus 5 times quantity of x minus 2 greater than 0. Now, since this one is greater than 0, if we're going to apply multiplication of integers, so positive times positive is equal to positive, and also negative times negative equals to positive. Meaning, if we're going to multiply like signs, the answer will be positive. So in this case, we can say that quantity of x plus 5 or x plus 2 is greater than 0, or quantity of x plus 5 times the quantity of x minus 2 is lesser than 0. Or they are negative, both negative or both positive. So to solve this one, let's have case number 1, x plus 5 greater than 0. So in here, we're going to have x greater than negative 5, or x minus 2, or x minus 2 greater than 0. So x here is greater than 2. Now if we're going to draw a number line, let's have here negative 5. Then let's have here, say, 2. So if we're going to have x is greater than negative 5, so from negative 5 greater than, so towards right, then x is greater than 2, so from 2 towards positive infinity. Now, to have your answer, just take the part of the number line where it hits twice. So in this case, if we're going to look at the graph, we can say that this part here from 2 up to positive infinity hits the graph or number line twice, meaning this is part of the solution. So we can have our solution here, x is greater than 2. Okay? And if we're going to have the second case, both are negative. So x plus 5 is lesser than 0. So we are going to have here x is lesser than negative 5. Second one is x minus 2 lesser than 0. So we can have here x is lesser than 2. Drawing a number line, we can have here 2, then this is negative 5. So this one is lesser than negative 5. So from negative 5 up to negative infinity, then lesser than 2. So from 2 to negative infinity. So if we're going to look at the graph, in this part from negative 5 to negative infinity, it hits the number line twice, meaning x is lesser than negative 5 is the solution or part of the solution. So we can say here that x lesser than negative 5 or x is greater than 2 will be our solution for this one. So just like the first answer. Example number 2. Find the solution set of x squared plus 2x minus 3 lesser than or equal to 0. So write the quadratic inequality in standard form. So this is now in standard form. Then find the roots of its corresponding equality. So make the inequality sign equal sign. X squared plus 2x minus 3 equals 0. Then factor. Quantity of x plus 3 times quantity of x minus 1 equals 0. Then zero product property, x is equal to negative 3, x is equal to 1. Then find the 3 test points. So if we're going to draw a number line, we can have here negative 3, then 1. So 3 test points is x lesser than negative 3. This one. Then second is x greater than negative 3 but lesser than 1. So from negative 3 to 1. And the third test point is from 1 up to positive infinity. So this is x is greater than 1. Next step is you're going to test a value from each interval in the inequality. So x is lesser than negative 3. So we can have, or we can use negative 4. So substitute negative 4 to x in the inequality. So we're going to have x squared plus 2x minus 3 is lesser than or equal to 0. So substitute x with negative 4. Negative 4 squared, 16. 2 times negative 4 is negative 8. Then minus 3 lesser than or equal to 0. Then solving that one, 16 minus 8 is 8. 8 minus 3 is 5. So 5 is lesser than or equal to 0. This is not true. This is false. 5 should be greater than 0. Then if x is greater than negative 3 but lesser than 1, so we can use here 0. Substituting 0 to x. So we can have 0 squared. This is 0. 2 times 0 is 0. So 0 plus 0. Minus 3. That will be negative 3. Lesser than or equal to 0. This is true. And if we're going to have the third interval, you can have false. So in here, we can say that our answer will be the second interval. X is greater than negative 3, but lesser than 1. And if we're going to test the roots that we have solved, x equals negative 3 and x equals 1. For x equals negative 3, this will be negative 3 squared, 9. 2 times negative 3 is negative 6, so 9 minus 6, minus 3. So 3 minus 3 is 0. lesser than or equal to 0. So 0 is equal to 0, so this is true. And if we're going to have for x equals 1, we can also have 0 equals 0, which is also true. So the solution set of the inequality x squared plus 2x minus 3 lesser than or equal to 0 is x, such that x is greater than or equal to negative 3, but lesser than or equal to 1. Now your clue here is the inequality sign. If the inequality sign is greater than or lesser than, then the roots that we have computed is not part of the solution. While if we're going to have lesser than or equal to or greater than or equal to, we can say that the roots here that we have solved are part of the solution. So for example, this one, negative 3 and 1 in x squared plus 2x minus 3 lesser than or equal to 0. Then let's have the second method, the sign graph. So the same. So write the quadratic inequality in standard form, x squared plus 2x minus 3 lesser than or equal to 0. Then factor the quadratic inequality. So quantity of x plus 3 times quantity of x minus 1 lesser than or equal to 0. So this is lesser than or equal to 0. So applying multiplication of integers, let's have multiplication of unlike signs will result to negative sign. So negative times positive is negative, then positive times negative number is also negative. So we can say that it's either the first factor is negative and the second factor is positive, or the first factor is positive while the second factor is negative. Applying this one to this problem, we can have x plus 3. So this is greater than 0, greater than or equal to 0. We can have x is greater than or equal to negative 3. And if the pair x minus 1 is lesser than 0, lesser than or equal to 0, we can have x is lesser than or equal to 1. Okay? Then using the number line, this is negative 3 here, then 1. So x here is greater than or equal to negative 3. So from negative 3, so this is now shaded because negative 3 is part of this one. Okay. Then x is lesser than or equal to 1. So from 1 to negative infinity. So looking at this graph, we can say that this part here from negative 3 to 1 hits the graph twice, meaning this will be our solution. That is why the solution here is x, such that x is greater than or equal to negative 3 but lesser than 1. Then there are quadratic inequalities that involve two variables. These inequalities can be written in any of the following forms below, where a, b, and c are real numbers and a should not be equal to 0. So this is how we are going to write quadratic inequalities in two variables. So using greater than or equal to, and lesser than or equal to. So the solution set of a quadratic inequalities in two variables can be determined graphically. So to do this, write the inequality as an equation, then show the graph. So these are image of the graphs for each quadratic inequality. Now if we're going to look at the graphs in greater than and in lesser than, you can see there that the line is broken. Okay? So the line of the parabola is broken. This means that the points being hit by these lines are not part of the solution. Okay? While in greater than or equal to and lesser than or equal to, this is a solid line, meaning all of the points being hit by this line are part of the solution. So let's have here example number 1. Find the solution set of y greater than negative x squared plus 4x minus 3. So first, write the inequality to its corresponding equation. So we're going to have y equals negative x squared plus 4x minus 3. Then second step, find the vertex of the parabola. So when you say vertex, that is the minimum or the maximum point of the parabola. It's either opening upward or opening downward. So if it's opening upward, then it has a minimum point, and if it is opening downward, it has a maximum point. So that is the first step, find the vertex. So finding the vertex, we're going to use the formula x equals negative b over 2a. So we're going to find the values of a, b, and c. So for this example, the value of b is 4 and the value of a is negative 1. So substituting that one, you have there x equals negative b over 2a equals b is 4, so negative 4 over 2 times a is negative 1, so 2 times negative 1. Then 2 times negative 1 is negative 2, so negative 4 divided by negative 2 is 2. This one. So to get y, substitute 2 to the quadratic equation. So you are going to have y equals negative of 2 squared plus 4 times 2 minus 3. So 2 squared is 4, so you have there negative 4 plus 4 times 2 is 8. Negative 4 plus 8 is 4 minus 3 is 1. So y equals 1. So the vertex here is the point 2, 1. Now next is you're going to construct table of values based on the vertex. So you have there the value of x is 2. So that will be your basis in using another set of points. So this is the value of the vertex here, 2, 1. So in this case, 2 is the value of x. So you're going to use x or x's 0, 1, 3, and 4. Okay? So to get the value of y, we're going to substitute x with these values. So if x is 0, then you can have y equals negative 3. If x is 1, y equals 0, and so on. Okay? Again, you will just substitute these values in the equality or in the quadratic equation. Then if you have table of values, after that one, you're going to sketch the parabola. So you're going to plot the points from your table of values for x and y. So first, graph the vertex 2, 1. So in this case, this is the vertex in here. This is 2, 1. 2 units to the right, 1 unit up. Okay? This is 2, 1. Then 0, negative 3, 0, negative 3. This is the point here. 1, 0. This is 1, 0. Then you have 3, 0. 1, 2, 3, 0. And the last one is 4, negative 3. This is the point. So after plotting these points, connect. Now since the given is greater than, so you're going to have here broken lines. Then after having that one, you're going to choose a test point. So for your test point, the easiest point that you can use is the origin 0, 0. Okay? So what you're going to do is you're going to substitute x and y with 0. Now if it is true, then you're going to shade the outer part. In here, this is the origin. So if this one satisfies the inequality, then you're going to shade this part here outside the parabola. And if this point does not satisfy the inequality, then you're going to shade the inner part in here. This one. Okay? Now substituting x with 0 and y with 0, we can have 0 greater than negative 0 squared plus 4 times 0 minus 3 in here. Then 0 is greater than 0 squared is 0 plus 0 minus 3. So 0 is greater than negative 3. So this is true, meaning you're going to shade the outer part of the parabola. This one. Meaning the shaded part are the solutions. Okay? Then let's have example 2. Find the solution set of y lesser than or equal to negative x squared plus 6x minus 4. So again, you're going to write the inequality to its corresponding equation. So you're going to have y equals x squared plus 6x minus 4. Then find the vertex using x equals negative b over 2a. So a here is 1, b is 6. So you're going to have negatives of 6 over 2 times 1. So negative 6 over 2 times 1 is 2. So negative 6 over 2 divided by 2 is negative 3. So this is the value of x for your vertex. And solving for y, you are going to substitute the value of x equals negative 3. So we are going to have here negative y equals negative 3 squared plus 6 times negative 3 minus 4. Then negative 3 squared is 9 minus 18 from 6 times negative 3 plus 4. 9 minus 18 is negative 9 minus 4 is negative 13. So y equals negative 13. So our vertex here, x is negative 3, y is negative 13. So the vertex is the point negative 3, 13. So again, you're going to base your values of x on the value of x in the vertex. So the value of x in the vertex is negative 3. So you're going to use negative 2, negative 1 for the left side, then negative 4, and this is negative 5 on the right side. If x is negative 1, just substitute x with negative 1 to find the value of y. So this is negative 1 squared, 1. 6 times negative 1 is negative 6. So 1 minus 6 is 5, negative 5. Then minus 4 is negative 9. Okay? For negative 2 squared is 4. Plus 6 times negative 2 is negative 12. 4 minus 12 is negative 8. Then minus 4 is negative 12. So the same process in answering this one, this 2. Then we're going to plot the points. So the first point is negative 3, 13. So negative 3, 13 is this point here. This one. Then negative 2, 12. Negative 2, 12. This point here. Then negative 4, negative 12. This is the point here. Then 5, negative 5, negative 9. This is the point here. Then connect. So the graph here is a solid line because the inequality used is lesser than or equal to, meaning these points are part of the solution. Then this next part, you're going to have your test point, which is the origin here. Okay. So using this one, if x is 0, y is 0, so 0 lesser than or equal to x squared, 0 squared plus 6 times 0 is 0. So 0 is lesser than or equal to negative 4. This is false, meaning we can say that 0.00 does not satisfy the inequality. So since this one does not satisfy the inequality, therefore we're going to shade the outer part, this one in here. But if this point, the origin 0, 0 satisfies the inequality, then you're going to shade the inner part. Next, what's more? Activity 3. Fill in the blank below to find the solution set of the following quadratic inequalities. So you're going to use your 3 test point method. So just apply what you have learned. Then for number 2, you're going to use the sign graph method. Then activity 4, find the solution set of the following quadratic inequalities, then graph and explain your answer. So you're going to draw here your graph, just like what I did in our examples. Then what I have learned, activity 5, determine whether the indicated ordered pair is a solution to the quadratic inequality y lesser than x squared plus 4x minus 5. Justify your answer. So what we're going to do here is we're going to substitute for x and y. For example, in number 1, point A with negative 2 as x, y as 5. Okay? So just substitute these values in the inequality, and if these points satisfy the inequality, meaning they are a solution. And if not, then it is not a solution. Then activity 6, you are going to match from the list of mathematical sentences the inequality that is described by the given graphs. So you have there 3 graphs, so you're going to select your answer from these items here. So activity 7, the direction, answer the questions that follow. So you have there questions, 3 questions. So just apply here solving quadratic inequalities in 2 variables. Then what I can do for activity 8, so you have there a problem, so just answer the questions. Then activity 9, another activity. So direction, perform the following activity. So you have there 3 activities that is needed to be done. So just follow the directions. The last activity is the post test. You have 10 questions. So write your answers in your paper. So if you have questions about these modules, so just comment below. So thank you for watching and have a good day.